Hey, welcome to a special edition of Shadow Partners Roundtable. This one is brought to us today by the American Concrete Institute, and it's going to be a good one. Hope you're ready for this. This is Reality Capture in Concrete Construction, again brought to you by the American Concrete Institute. My name is Jeff Eccles. I'm a senior advisor and the head of marketing for Shadow Partners. My role today is just to facilitate this conversation and let these experts talk about reality capture in concrete construction here. So I'm going to start by going around the table and just very briefly introducing our panelists today, and then go back around the table and let them go a little bit deeper. So starting in what would be the upper left, Rex Donahey, Director of Innovative Concrete Technology at the American Concrete Institute. To his right on my screen, Matthew Byrd. He is the founder and president at the Reality Capture Network and Nexus 3D Consulting. And at the bottom of the screen, Chaitanya. He is the CEO at Constructn.ai. So to the three of you, thank you very much for helping us put this panel together, and Rex to ACI for really spearheading this conversation. And I want to turn it over to you, Rex, and just give you the opportunity to give us a little bit better introduction, better than I did, of who you are, what you do, and what you're concentrating on at ACI.
Thank you, Jeff. I've been with the ACI for about 20 years now. I've started off as the editor-in-chief of Concrete International magazine. And we have about 30,000 readers worldwide, and we try to communicate with people about concrete, its uses, problems that they're having, and how we can fix them. And a little background, because ACI has this magazine, it helps the organization meet its mission, which is to develop, disseminate, and advance the adoption of our consensus-based knowledge on concrete and its uses. And ACI has certification program for individuals that are producing or testing concrete. We have educational programs for engineers as well as contractors. And then we produce a number of standards and codes. In particular, we have one code, the building code. I think it's used in some form or another in, I think, 86 different countries around the world. It's pretty remarkable stuff. All of this stuff is consensus-based. It's committee work that's done by volunteers. We have a staff of about 100 here in Farmington Hills, Michigan, that helps collect the information and get it produced for them. My role changed about 2 years ago. I became the Director of Innovative Concrete Technology. And one of my purposes in that role is to identify emerging technologies that can be developed within ACI's technical committee structure. And I also am trying to make contacts with innovators like NK to make sure they're aware of what ACI represents and how he might contribute to our knowledge base. We also, one of my other responsibilities is to work with VCs and try to connect them. I get contacted by startup people who are startup people with executives, founders that are looking for funding or looking to make connections, and that's one of my roles. Reality capture obviously is one of the major issues with us because it affects productivity and quality. So what I'd like to do then is just move forward and have Matthew introduce himself. He's kind of the reality capturer for the reality capture field. So I think it's important. Let's start with that.
That's great. Yeah, well, thank you. Great introduction. Thanks for having me as well. So my name is Matthew Byrd, and I do a few different things. I started my own land surveying and laser scanning company about 7 years ago after growing up in the survey world. And initially, our focus was really around terrestrial laser scanning for collecting existing conditions information in oil and gas facilities, and then started expanding from there into our traditional survey work. And over the years, we just started seeing this adoption of laser scanning and drones and point clouds, and seeing the use case for the technologies across so many different industries. It started pulling us into architecture and into buildings and into forensics and into just so many different areas that we weren't even really working in before. And that also then led to the Reality Capture Network, which we started as a podcast. And really now we're seeing a need for more education in our industry of all the different technologies that exist and all the different use cases for them and how they get applied, and how you control them, how you keep them accurate. And so that's really become the big passion project for me is education around these technologies. So happy to be here and share whatever I can today.
Okay, great. Thanks, Matthew. And then NK, you're one of the top people in this technology. I know you're still in stealth mode, so you can't give us a lot of details on what you're doing, but you can certainly talk about your background and where you see the industry moving.
Surely. Again, thanks for having me, everyone. It's a pleasure to be in this company. And to introduce myself, I'm NK Chaitanya, and I'm the CEO and co-founder of Constructn. So Constructn is an automated construction monitoring solution, which is data source agnostic, which is multimodal. Like, you have so many reality capture sources. So we can consume any of them, right from a drone, a laser scanner, 360 camera, mobile phone, mobile LiDAR, or even a robot with all these sensors equipped in it. So we said we'll be the first solution which is actually multimodal, consumes all this, and gives you deep integrated insights on where the project is at versus where it's supposed to be. Like deviations in terms of schedule, deviations in terms of design, tolerances, or even quality. All of this can be automated through AI was a perspective. And contrary to Matt and Rex, right, I'm relatively new in the construction domain. Like, I've been here for about in this domain for about 5 years now. Although I've been having 15 years of experience in technologies like robotics, AI, 3D vision, motion capture, and virtual reality. Now, there were different domains that we applied these technologies to. I started out in the medical domain, now where the tolerances were very, very low, right? You had to be having really, really accurate data. And from that medical, I moved to home automation, industrial automation, 3D robotics, to finally, smart cities and then construction. So this has been my journey. So I have applied this across various industries, obviously not as much as Matt, I'm sure, but this has been a fun journey. And the ability to perceive the world in 3D and generate insights out of it has been what has been my driving force. So this, especially applied to the construction industry, is what I'm super passionate about, and happy to have this discussion.
Super. So the interesting things that, well, you said several things that were fascinating to me, but one of them was this multiple source ability. You can take information from almost anything. It could be photogrammetry, it could be a laser scanner. Could it be infrared and other data then as well? So you can take in anything that's digital and evaluate it. And you use the term tolerance. When I think of tolerance, I'm thinking of, perhaps the flatness of the floor, the elevation of the floor, how it varies. I might also be thinking of the drape and post-tensioning tendons. So when a floor is cast, the contractor will be installing the tendons within a certain horizontal dimension over the width of a floor, but then they'll have Z-dimensional change as they move across. Are you able to measure dimensions to, let's say, 1/8 of an inch or a millimeter based on data? And if so, what do you have to do that?
Perfect. So two questions, Rex. Let me take that one by one. The first one being, on multimodality and what kind of information sets are we able to consume today? So today, the data sets we are able to consume are predominantly visual, and that includes thermal infrared sensors as well. Like one of the use cases that we actually worked on is the solar plant. So
Mm.
during construction, you measure the solar plant, but post construction is when you want to actually look at the defects, or areas where the productivity is low or the energy generation is low. And these come by, is there any shading, is there any cellular defects that are actually causing it? And thermal cameras are a great way to do that. So thermal camera, yes, but we have not gone to the level of sensory data. Right now it's all visual data. So thermal also I would count it as visual data,
Mm.
but there's so much more you can do, right? Concrete sensors and all this come under different domains, but we are focused on the visual part. Now to your second question on tolerances, right? And this becomes very, very interesting because some of our customers, for example, ask millimeter level accuracy. Some of them ask, I'm good with 1 inch, 2 inches, 3 inches. So it's all across the block. Now, what I have realized across these things is that's the reason why there are different tools that exist. You have the terrestrial laser scanner if you need that 1/8 of an inch or
Mhm.
1/16 of an inch, for example. For doing simple things like progress monitoring and productivity tracking, a simple thing like even your cell phone may suffice. For doing basic level measurements, like I want to see how much plastering has been done on the wall, I don't care too much about the accuracy. Then maybe even an iPhone lidar might suffice with that. So it's all about the use case. The way I look at it, this is like a toolbox, the reality capture toolbox, and you have so many different tools. Each tool has a different purpose and different application. Floor flatness, terrestrial laser scanner. Progress monitoring, maybe a drone scan with a 360 scan will do. And where this gets interesting moving forward is, say, a complete robotic solution which has all the sensors integrated together and working in tandem. That makes it completely autonomous and very efficient to get it. So that's my long answer to the question on tolerances. Different tools for different purposes, but there has to be one interface, is what our perception was. Our entire vision was there has to be one tool that is able to actually analyze all this data so that you're not shifting between 10 different tools to look at what is going on with your project. That is essentially what anyone wants to know.
Super. So the tolerances can be measured. It's a function of the time in acquiring the data. So Matthew, have you seen any major progress in speeding up that data acquisition process to get the precision that some people want quickly?
Yeah, that's a great question. I still believe that right now, this is one of the biggest challenges in our industry when it comes to reality capture technologies, is that there's not a lot of great resources available to help users understand what types of gear is the best fit for the type of project and application. And then even when they identify what type of gear, what workflows are needed in order to keep a certain tolerance. For those that maybe aren't familiar with laser scanning, we could use a quick example. So when you look at a terrestrial laser scanner, right, there's 12 different kinds and brands from Trimble and Leica and Faro and all of these different units. And when you go out and do terrestrial laser scanning, I like to say it's kind of like puzzle pieces, right? We say we have a 20,000 square foot parking structure. Well, in order to capture that parking structure properly, you're taking your scanner and you're setting it up every, 10, 20 feet, 30 feet, 50 feet in order to get different, line of sight on different aspects of the structure. Now, by the time you're done capturing that 20,000 square feet, you may have 50, 80, 100, 200 laser scan setups. There is error that is built up between every single laser scan setup. There's a little bit. And so you get this accumulated error effect through terrestrial. And if you don't do proper control processes, how much error is built up from one end of the parking structure to the other? Or if we just go out there and scan and we maybe don't have any secondary control or secondary measurement methods, how do we know that if we want to do a floor flatness on the concrete, how do we know that our data is leveled properly when we actually go to use that data? So there's a lot of question marks when we look at the use of the technology, which tool we use, which workflow we use, and then how can we actually verify that our data is accurate enough to use for, that use case. So one of the things that I try to talk about a lot is trying to dig in deeply to look at comparisons of technologies and workflows required. One thing that I think is not talked about enough that I just keep pushing is the knowledge around survey control and traditional survey practices and survey networks and the integration of those into all of these reality capture technologies, especially when a high accuracy need is there, or, you're talking about construction. If you go out to laser scan and now actual buildings are going to be built off of your data, who is liable for making sure that the accuracy of, the data is there? So the thing I like to suggest is, one, anybody that gets into laser scanning, dig in and understand survey as well, understand survey control and the purpose behind it. And then you can work toward what is the best scanner for your type of work and how do we apply it properly to get those tolerances. And I know that's a long answer, but I wanted to hit a little bit on the need for those accuracies and workflows. But your question also about, do we see speed improving and can we get there faster and is the accuracy there? Absolutely. The scanners and the technology have been changing rapidly over the last 10 years. From there was no cloud to cloud registration 10 years ago, everything was manual target based. You had to have all this control, and you still need control on most jobs, and survey is important. However, the scanners have become way faster. If you go back 10 years, a single laser scan station probably took 10 minutes, 15 minutes. Now we've got things like the Leica RTC and the Faro scanners that you can do a single laser scan in 1 minute or 2 minutes. Like, the speed has improved on those. And then there are things like mobile scanners like Navis VLX Backpack and GeoSlam handheld scanners where, depending on your density and your accuracy needs, you can capture that data while walking. So the technologies have definitely been improving a lot.
So is there any possibility that you could have a hybrid where you had the terrestrial scan that established precision within a small area? You maybe had one or two setups so that your personnel weren't out there doing that, and then did a quick overview of a larger area, say a building footprint, using an aerial drone with LiDAR on it. When you do that, I'm sure you build up error as you move away from the initial point. But I'm wondering, is there some way that software can make corrections for that?
Yeah, my initial feedback on that is we do like mixing technologies, and you absolutely can. And survey, again, control really helps with that. So if we go out to a job site and we have survey control on the ground and we shoot in some targets, if we fly it with the drone and we have ground control that's on that coordinate system, then the drone data is going to fall right where it's supposed to. And then if we go use a terrestrial laser scanner and tie into the same coordinate system, that data will fall right where it's supposed to. So you can piecemeal those technologies together properly. However, you can't necessarily say, hey, if there's accurate terrestrial data and I now go do mobile data, will it be just as accurate? Can I improve the registration of those? That there's still probably a little bit of difference in, the gear you use will determine the accuracy of that data set. And so typically, if we're going to mix technologies, we look at, okay, maybe the accuracy needed on the inside of the building is different than what the outside site or the roof is. And so we might take one job and use 3 different technologies, but use the right technology for each area.
Super. I'd like to introduce.
I hate to break up the flow of this conversation, because this is a really good conversation. I'm going to bring in some of the chat that's happening online as well. But first of all, I want to thank Eric Peterson for his patience in working through the technical difficulties. that we have. And let me just take a minute and say that Eric Peterson, he's the director at Webcor Concrete Group. He's joined us now. And Eric, you want to take just a minute to introduce yourself a little bit further, go a little bit deeper, and tell us who you are and what you do?
Sure. Sorry about that. I had to use my own computer because our company security plan wouldn't let me access all the functionality. I've been in the concrete industry for about 50 years. I'm an old guy. I got into scanning in about 2014. I did it intermittently for a while and very steadily from about 2016 until now. Right now, our company is using basically 3 platforms for reality capture: 3D laser scanning, drones, and we're doing some experimentation with augmented reality, where basically we travel around in the model on the job site, taking a look at what's there. I work for the Concrete Group. Our company is a general contractor that has a number of self-performed divisions. I work in the Concrete Group and have for the entire 23 years that I've been with the company. And before I started laser scanning, I used to do a lot of random surveys of projects to see, what our quality was like. I ran projects for many years as a superintendent. And so I would take a total station and I had a whole list of things that I would randomly check. But in our trying to understand what we could accomplish this way in terms of understanding what kind of quality we're producing, I realized that there just wasn't enough of a sample set to really be able to establish a conclusion with a confidence interval of any significance of what the quality is that we're producing in the field. So I first met Philip Lorenzo. A lot of people know him at the World of Concrete, and I at the time I was the chair of the ACI's Tolerance Committee 117, and I noticed that he had just recently joined our committee, and I said I need to meet this guy, and my boss said, hey, these guys got a booth over there. Why don't you go check it out? And when I went there was Philip Lorenzo. So I started talking to him right away, and I started realizing that laser scanning was a way for me to capture 100% of what we're building. And then, so since then, I've been trying to use it more as a proactive tool rather than something of documentation purposes. I try to catch things before they happen. And so I'll scan mats before we pour them, and check all of the reinforcing steel and make sure that it falls in line. All of the scans I do are registered to control. I was listening to your discussion a little while ago about how you verify the accuracy of what you're doing. I go through the registration reports very, very carefully before I plant the registration into the model. And then I look at the model and make sure that, things make sense. I'm not a surveyor like Matthew. I'm a carpenter by trade, but I work pretty hard to make sure that everything I'm looking at looks accurate, and I try to verify it with secondary means. If I tell somebody that a wall is off by 2 inches and 2 1/8 inches, they go out and measure it and they come back and give me the same number. I feel pretty good about how things are lined up. So I've been doing pre-pour scans on mats. I've been doing pre-pour scans on slabs, checking embeds, blockouts, edge form, reinforcing locations, some cases post-tensioning locations, just trying to make sure that everything's in the right spot before we pour, and both for elevation and XY. And it's been working pretty well. The only disadvantage I would say that traditional scanning has is that you have to physically be there. And oftentimes you have to be there while work is still going on, which makes the stability of your instrument difficult to maintain. And also it's hard to do those kinds of measurements on the day before a placement without somehow interrupting the workflow. So I've worked around that a lot, and people know who I am, and they give me the courtesy for whatever couple minutes it takes me to make a scan, and I get things done and move on and try to get them the results overnight. But that's what I've been doing. It's been very useful. I wish I could show you some of the product. I had some slides set up to show you what we do, but I can't do that with this computer.
I'm sorry, we don't have that capability. Eric, you said something really interesting. You said proactive action. You're taking the scans to improve quality and
yeah. And I mentioned that when we had a conversation before this, and I mean, when people know things are being measured, it makes a difference to what they focus on. I mean, we have one of the things our company prides itself in is having very short cycle times. We build a lot of buildings, and we try to do very well on our cycle times. And so the idea is to get everything right, but not sacrifice our schedule, right? So there's two things that happen. One is if I can give them feedback, even if it's on the morning of the placement, that there's some things that need to be corrected, they figure out a way to do that. Even if they change where they're starting to pour or whatever, they get in there and they fix it because it's important enough that it would cause rework later on or cause some kind of difficulty later on. So they'll make that happen. The earlier I can give them the notice, obviously, the better. And for example, Thursday this week, I'm going to scan the level 23 roof of a building that we're building on Treasure Island. And there's over 200 embeds in that roof. So fortunately, we're pouring on Monday. So that gives me a night and a day to process it. And these guys are going to have some time to do whatever needs to be done. But that's what I mean by proactive, is just trying to get the information out there in advance. And when I look at a deck, like a lot of people focus on wet scanning, and I haven't seen the advantage of that, although I think there could be an advantage to doing it, especially on steel structures when you're looking at beam deflection and things like that. But every sleeve, every block out, every edge form, every construction joint, anything that's set in the slab that defines the top of slab, you could go out there and wet scan on the day that you're pouring, but if you haven't made sure that all that stuff's in the right spot, you're going to still pour a slab that connects the dots, and you end up with a slab that doesn't, meet tolerances in one way or another. So I'm really into the preparation side of it rather than the post-pour side of it. I want to make sure that we have at least a fair chance of achieving something that's correct.
NK, what can you do with your system and your artificial intelligence to give Eric back his weekend before a Monday pour?
Right. And that is exactly the vision that we started Constructn, right? Because the people working so hard on site, like Eric, doing all the scans, is there a way to automatically register it to some level? You have the control points. Obviously, you need the control points. But is there a way to seamlessly ingest that information and do the registration to an accurate degree? Now, that is the theory we are working on. Like phase one of Constructn was about getting your progress monitoring right. Now we have gotten to that level where we got very detailed, accurate results to even much smaller items, right? People say, MEP lines are difficult, your conduits are difficult, ductwork is difficult. So we were able to measure, quantify all of that, and we are making good strides on that. But then the next challenge and the most challenging bit comes is automating the tolerances and deviations. Now, deviations and tolerances, generally, if you look at the complete BIM and compare it with the reality scan, what is happening right now is you get it at a lot of different places. And maybe some places it's okay to have that. So the only way the intelligence will work very well and it will assist people like Eric is have the tolerances baked into an element level and then actually give out the deviations. So that is what we are actively working towards right now, Eric and Rex. So that this next phase of development we are super excited about, where we can actually go to a very, very detailed level.
So what can ACI do to ensure that as we build into these technologies, the technologies are proactive rather than punitive? I know early on there was some fear that we'll get so precise with these scans, we're going to give a malicious owner a weapon that can be used. We have imposed tolerances on ourselves that may not be realistic because we don't have enough data. But now we've got the capability to collect that data. Is there some way, and I'm going to ask this of Matthew, do you think there's some way we could have a database that or some kind of a resource that allowed us to accumulate data from multiple projects so that we could develop the statistical analysis that would tell us what a realistic tolerance was on the placement of an item for concrete. Eric, is that a fair question?
Yeah. So yeah, there's two subcommittees in Committee 117 on tolerances. One is concerned with laser scanning, and that's actually chaired right now by a man named Leo Zhang. He's got a lot of good energy, and I think there's about maybe 10 or 13 people on that subcommittee. And anybody that's interested in that, you can contact me or try to contact Leo. He's with Conco Concrete. And then we also have a data subcommittee where the whole object of that committee is to try to collect data. And the important thing about collecting data is that it needs to be acquired using the kind of the same, not methodology, but the same format, so that one data set can be compared to another. And that's all kinds of tolerances, things that you wouldn't necessarily evaluate with reality capture, but whether it's pavement thickness to the plumbness of a core wall to edge form accuracy, embed accuracy, things like that. We would like to have, as a committee, a lot of data. But right now, getting contractors to take time out of their short-term schedules, or their short cycle schedules, I should say, it's really difficult. By the time you're ready to build something, you need to move on to building the next one. So it's difficult for a contractor to have that sidestep of collecting data for that purpose. So any help we can get in that area, I think, would be useful for establishing tolerances and also establishing protocol and how you collect this information.
Yeah, I agree. I'm happy to just throw in a thought there as well. And that's the piece that I'm trying to put a focus on the aspects that I understand. I'm not the builder. I'm not the guy in construction. I'm not the engineer. I'm not the structural guy. You guys are the experts at knowing what you're building, what information is useful to you, what standards you want to meet, the accuracy you're trying to meet. What I have dug deep into myself is all the capture technologies, is understanding the difference between using a SLAM-based, laser scanner versus terrestrial, understanding where to place targets and optimal overlap for different units to meet a certain accuracy. And those are the challenges that I've seen is, a lot of companies get sold, hey, buy this laser scanner, and they get very quick training. But then, Eric, I'm sure you can tell some stories, and I know I can, of, we've had to learn the hard way sometimes of exactly how to get through registration problems. And we go and slice data, or somebody else comes out and scans for us, and we look at point clouds, and you look at the floor, instead of it being one nice slice, you got multiple levels, and you look at a wall and there's deviations. And so, if we as users, whether it is a GC, whether it's a survey company, whether it's a scanning company, whoever it is that's capturing, if we don't actually know really good processes on how to capture data accurately, then if we go and use that data to try to look at a floor flatness and our data is not accurate, then we're not going to get good results. We can't even, hold, if we do want an accuracy standard, we can't do that if it's not collected properly to begin with. So I would love to continue helping and contributing however we can. Things that we're putting some focus on, for example, are doing some comparisons of taking a test project with solid control and scanning the same exact site with 10 different devices, and then doing comparisons to showcase people what happens if you do, as mentioned earlier, try to capture a piece with an iPhone or a Matterport or a Faro or a Trimble or a Leica or a mobile scanner. What are the real differences? What's the real accuracy difference? What can we trust for what types of projects? So then we can build out those actual workflows for, one, people who are doing it now that maybe keep having issues, and two, as the desire for all these technologies grow, which they are right now, it is just massive interest in more and more and more of this. How do we define processes and procedures or standards or certifications or something that helps give some confidence in how it's being captured and how that data is being used?
Yeah, so right now, I think our subcommittee the attempt is to write a tech note. And we're going to choose, like, from all of the tolerances that 117 publishes, if we're going to go out and we're going to check edge of slab location or something like that, what would be the correct protocol to use a laser scanner? What would be the correct protocol to use a drone? What would be, you know what I'm saying? How do you check it starts with the calibration of the instrument, to the registration, to the survey that's conducted to establish, you know, the reference points, you know, to have something that can be used to go out and accurately determine, you know, a tolerance. In reality, though, I mean, when I do a scan, if I scan, for example, a slab post pour, and I just want, you know, and that's done so that we can monitor future deflection and we can see how our finishers did. I mean, we get a lot of information from that just to try to move on to the next slab and see what we want to do different. But I also can just bring that scan clipping up about 3 inches and I can see where every vertical element is in that deck. So we don't do a scan and just walk away with one piece of information. You know, we walk away with a very comprehensive look at things. And if somebody wants to look at something in particular, sometimes we go back in the you know, months after that's been done to go back and look at something and see where was that before we poured, you know, that kind of thing. So, but it is important from the 117 point of view that we do have a protocol that basically everybody is following if they're going to verify tolerances with this methodology. And right now there's some considerable doubt as to the capability of this methodology to be used for certain types of tolerance evaluation. So that's something we have to get beyond. Either say yes or no, and then on the ones that we say yes, have a method for doing it.
And just to add to that point, right, Eric, you're spot on with that. And there are different tolerances which need different measurements. Like for some tolerances, I'm looking at a single column, for example. Maybe relative accuracies are good enough. You don't need absolute accuracy to look at that. But there might be cases for the entire floor flatness, you need absolute accuracy. So, you know, balancing the data type and the methodology and education on that for the data collection would be super important.
Yeah, I mean, taking tolerances on vertical elements, for example, I mean, they vary as a function of height of the structure. That's when I'm telling someone how their core wall is located in a high rise, I can take that into consideration. I can figure out the height of the building above the ground, above the base of that element, because that's where it all starts, is at the base of the vertical element. And I can let them know what they're deviating. But when I bring a scan into the model, I look at the ideal location every single time. So what tends to happen is I tend to keep the vertical elements a lot closer than they would normally be kept. Because if there's rebar cage that's pushing the boundary of being inside or outside of the modeled location of that element, there's a tendency for the guys to go, okay, that column's, you know, an inch west of where it should be, and they start moving it back. So things tend to migrate back to the right locations. But in reality, if we're 300 feet off the ground, you know, they maybe only need to be within a couple of inches and they're fine. What's also happened in the industry is that some tolerances that are published within ACI don't work well for other industries, whether it's curtain wall or elevators or you know, stairs or something like that. So oftentimes in the contract specifications, we will have more restrictive tolerances than we might have in 117. And so those are the tolerances that I pay attention to on a lot of structures, because those are our establish our limits.
Yeah.
Well, I've heard about 3 ideas for articles already in this discussion. So, thank you.
Yeah.
Looking forward, how much time do we have, Jeff?
I think about 15 minutes, and there are some interesting comments and questions showing up in the chat over on the right side. Ian, and I promise this was not planned, but Ian is from Shadow Partners. He said some contractors are skeptical to use some of these tools. That may be because of labor shortages or skills deficiencies. What do you say? How can you demystify this for a GC that's not using this technology yet? How do they make the leap? Maybe is the question.
Well, there's a big choice of doing it self-performed or having it done out of house. When we started scanning in Webcor, I don't think that there were very many out-of-house companies doing that. But that's a decision that a company needs to evaluate. And there's a lot of options out there right now. I mean, for the X and Y, drones do pretty well. I mean, if you use the drones well, you can tell if you've got an embed that's not there or it's in the wrong place. The same thing with the edge form, things like that. What we've seen so far is we're not getting real good vertical control out of drones. Maybe Matt or NK, if you know differently, you can interrupt me, but we get better vertical information from a scanner than we do from the drones. But a lot of the battle in getting things right in construction is in the XY plane. So, that's one way of going into it. And so there's ways of having this kind of oversight of making sure that you have things right without developing that skill set in the house. If you already have like a survey or a layout department within the company, you could get somebody that's learning how to do that and try to introduce it, slowly into one job at a time until you find out what it's useful for your particular company for, and then let that propagate. But like Matt was saying, learning how to register for me has been a many years venture. I mean, I am constantly learning how to refine my registrations and what things I need to worry about in a registration to get it, to fit a project well. It's not something that I learned overnight, but I think that there are places where you can learn that. Mostly the manufacturers will teach that process. And my advice is don't let them off the hook until you can actually go out and do something. They're happy to sell you the scanner, but at the same time, they should also sell you the technology and the knowledge.
Yeah, I'd love to give feedback on that as well. That's just a place, like Eric just said, it's taken years to just keep refining and learning on our own as we're trialing things. And, I don't put any bad word to the manufacturers either. They're all doing their job. They're creating the technology, they're selling it. But a lot of the people that sell it too, and a lot of the people that do the initial training are also not the construction people. They're not surveyors. They haven't done hundreds of major projects and worked through headaches and like had that hands-on experience. So it's often that the users of, Eric and myself that doing the scanning, that we end up with the majority of the knowledge on really the best practices and the workflows, which is where my shift over the last couple of years has started realizing we're to the point in the industry with all these technologies that there is a lot of knowledge out there, but most of it is stuck with individuals and individual companies. And there hasn't been a lot of good available resources to say, let's create those best practice documents to help those of us that are, just started last year or just started 2 years ago, that are still going through the headaches that maybe we learned, 6 years ago. We can start creating educational content, training material, case studies, which also I would say leads back to the question of how do we get people to adopt the technologies that maybe are hesitant in it or struggle with it. As a service provider, I'll tell you the best success I've had is, showcasing examples. So, doing a pilot project with a company who's hesitant and saying like, look, here's what we believe this will do for you because you're currently doing it this older way, coming in and scanning will help with XYZ. We do a pilot project and you prove out that first job. And then if you even just create educational content from a pilot you did before, now you have educational material you can come in and present and say, here is how it changed the process for this other GC, or here's how this other survey firm is integrating drones or scanners. Or I believe education and educational material and content is what can help us with the adoption of the technologies and really the growth of the entire industry.
So what's the consensus? Is this something that should come from an organization like ACI, or should it go up higher, more at the GC level? Or should it come from Matthew?
I've really wondered that question myself. And, I haven't seen a lot of people taking a deep dive into creating that type of content. So it has become my focus of, instead of me putting a focus on just growing my services side, I'm kind of shifting myself to saying, look, I see so many people adopting the tools. I actually just want to start helping more people do better with scanners and with drones and with how to control them and how to register them and how to. So that is something that I am actually putting a focus on, is helping gather that material and work with vendors to, come up with case studies and best practices and training. And so it is something we're working on. But I pose the question too of, is an organization going to come out with some of those documents? Is there going to be a certification? That's another big thing as a survey company. I don't ever push and say, hey, only surveyors can laser scan. I don't believe that. But what I do know is that survey has become a very critical part for us in order to keep data accurate. And so surveying has a license, right? Just like an engineer. Well, all of these new technologies, laser scanners, they are mapping tools. They have different accuracies. And we are bringing them in and relying on them for very, big projects that could have a lot of liability. And so does an organization at some point create a certification process that helps, people who are hiring scanning companies to know and validate the knowledge of a company that's going to scan? Or these are all things that I'm curious of as well.
Yeah. So on that, if I think that something's going to go to some kind of legal claim process, or if it's going to be something that's very critical for a record of some type, then I know to go out and get a licensed company to do that. If I'm scanning a deck just to make sure that we have something right the night before a pour, I feel pretty confident in doing that. I think it's knowing your limitations and what the scan is going to be used for. Scans themselves are just collections of points. I mean, the scanner is a data collector. That's what it is, right? It broadcasts laser pulses, and it comes back with information. So I've turned my raw data over to surveying companies to process for various purposes, and they've been able to get basically the same results that I did. So that's why I think it's important to retain the data. I've retained the data from every scan I've ever done, which occupies a lot of terabytes. But you never know if it's going to be necessary to look at something like that later on, and why throw it away? So it doesn't cost that much to keep it. I keep it actually on portable drives right now, because I was seeing somebody commenting, I think Brian's talking about using Ignite. I understand that that's a very good platform for transferring large data sets. But as of right now, I'm just retaining it in case. But knowing the limit, my point was just knowing what the scan is going to be used for, and then saying, are we the right persons to be doing this, or should somebody else be doing this, to understand what the downstream use is going to be.
And that's where I just believe that together as an industry, we have to help educate on that piece, because that is the challenge today. So say there's a new GC, right, that isn't scanning yet. Where do they start, right? What tool? How do they know what tool to use? How do they know what workflow to use? How do they know, hey, this is a project I should or should not do myself, or accuracies, or, that's where it's difficult. It's been difficult historically to find good information to help make those educated decisions. But you're absolutely right, Eric.
I do totally agree to what Matt and Eric are saying, right? Like today, as an AI tool, I can come and tell, I'll give you tolerances or deviation analysis up to 1/16th of an inch. But it's my ethical responsibility as a company and myself as well to tell the user it's about how accurate the data collection has been, what's the registration been, what's the methodology and workflow like, because that is what, the best AI engine is as good as the data it gets. And if there's no proper mechanism to get the data right, your results will be way off.
Yeah, I mean, I've found on some jobs, like typically I don't survey the targets myself. It's done by the job layout crew, right? So they'll stick the targets up in advance of me being there. They'll get them all surveyed, and then when I leave, I take it with me on a USB drive. I have all the coordinates of the targets that were in the survey. And that's, with the type of scanner I'm using. that doesn't resect itself or doesn't acquire its position in any other way. But then I've gone back and I've done the registration, and I've realized that the targets don't fit each other, that their measured versus calculated values are not the same. And then I've had that happen, like sometimes repeatedly, and I'll let the job site know. And then sometimes that's how I find survey control errors, is by realizing that I can't make the targets fit. So learning to get dialed into something like that, to say, hey, is this a scan problem or is this a survey problem? And being able to get to the point where you realize it's not a scan problem, or it is a scan problem, to try to get down to that. So there's a lot that goes into making sure that you have things accurate. And sometimes you find things from scanning that you didn't expect to find.
And I'll throw out one last comment on that piece, is that I believe that's why it's almost, when it's a critical project or accuracy is important, having two methods to verify. If you have the control and the scans, you can double check each other. If they both look good, great. If one looks bad, then okay, I have a reason to look further into it. Is my registration off? Is the survey off? The problem with a lot of people today just buying a scanner and running out and scanning and not understanding that process, or not understanding survey, is how do you actually know how accurate your scans are? If you don't have a secondary control, check, you can't confidently say. And the fear of that, if you're doing it in construction, and again, big projects where people rely on that data, is you do now have the liability if something goes wrong and you didn't check it properly. If it does come back to, well, where did we start from? Who collected the data? How was it collected? So I see that secondary survey, even though it's easy, get a local survey company out, shoot the targets for you. You can scan. You don't have to have a survey internally. It's your insurance, right? It's your secondary check. You know that they checked it. It's that next level confidence in your data as well.
Hey, Andy's got a question here on FL reports, and some of the laser companies won't really like me very much for saying this, but I view doing FFFL reports with a laser scanner the same as chartering a jumbo jet to cross the street. It's you get what you get out of it. You still scan the entire floor. And yes, by the way, it's an ASTM procedure. So technically, yes, you should be certified to do an FFFL report. In fact, I am a certified F number technician. I took the course from Alan Faye's company and got my certification just so I had a better background for understanding FFFL reports and the whole process in the first place. And anyway, when you scan an entire surface and then you go back and lay down some lines on that surface to evaluate the F numbers, it gives you a 90% confidence interval that those lines represent the slab. When we scan the slab, we see the entire slab. And from a set of lines, there's very little actionable information. You know whether or not you met the contract requirements, but you don't know where you have to go out and fix a door swing, or where you have to go out and fix something that's not going to work well for drainage. When you scan a slab, you produce a good heat and contour map, and you produce maybe an as-built elevation report or something like that. You look at that and you say, okay, there's something that we have to do right there. And you get actionable information out of the scanner. I've had people prove to me, very reputable people, don't know a lot about the mathematics behind FFL, the F number system. They feel confidently that a scanner doesn't have the accuracy necessary to produce FFFL reports. I've tried doing it. I've laid out the lines. I've snapped them on the floor. I've had the person using the meters for walking the lines do the same start point, same finish point, went all the way through. The results were within 10%, and that's all I can say. And we did a number of years ago, Bruce Supernaut with ASCC organized a precision and bias study to see what could be done with F numbers on a slab, and the results were very variable. That's about all I could say. Is that it wasn't in his article that he published in CI. It was written with also with Jim Klinger. It was not as accurate as we'd like it to be. But I also don't think that that's necessarily a good use of a laser scanner, and that's just my purpose, my own opinion. I'd rather look at something beforehand and make sure that we have the best chance of getting it right than spending my time looking at what we did and wonder, why it's not what we wanted it to be.
We're running up against time at this point. And for those of you that have joined us live, you may notice that we're already past the top of the hour. We got a little bit of a late start, so we're going to run a few minutes beyond. And there was a question earlier, can I watch this video later? Yes, you absolutely can. Wherever you're watching this right now live, the video will remain there on the platform, LinkedIn, YouTube, wherever. As the head of marketing for Shadow Partners, I should also say you could just go over to the Shadow Partners YouTube channel and find it there. But wherever you're watching this video right now, you can rewatch the recording of it later if you missed any part of this or you want to review, et cetera. So I want to throw that out. We're, like I said, we're headed to the end here because we've been going for an hour. We need to wrap it up. Maybe what we do is we go around the horn, starting with you, Eric. Any final thoughts, any final remarks regarding reality capture, all the different techniques that we've talked about, the tools that we have been talking about? What do you want to leave people that are watching this? What do you want to leave them with?
When I started in the industry, we were still using manual transits with vernier scales, plumb bobs, and everything was measured by hand. We're now going to where we use robotic total stations, where the information comes off of the model, Autodesk point layout, goes into the field, and gets laid out. This whole process of taking human error out of the operation of accuracy in terms of building things is only going to get better. The tools are going to get better with augmented reality and further advances in LiDAR and things like that. So I think what really needs to happen is we have to figure out ways of having these processes be less intrusive and consume less time. We don't want to wait hours or overnight for a report. We want to know right away. So the emphasis, in my opinion, is getting this right and getting it to happen quickly so that, that we can maintain the accuracy that's necessary for what we're building.
Great. That's great. Great advice. Great goals there. NK, you want to go next?
Sure, Jeff. So I also am super excited about the future of reality capture. And I believe, for one, like all the modes of reality capture will exist together. Like you will do daily scans with a 360 camera, and most probably it will happen out of an autonomous robot or a vehicle. You will do, LiDAR scans for doing relative accuracy measurements. Then you'll do laser scans for the tolerance measurements. But all these tools will exist together, and it will become better, faster, cheaper, and more accessible to a wide range. Someone building a single family home to someone building a huge airport. These tools will be accessible to everyone. So that's why I'm super excited about this space and love the insights on this conversation. Thank you.
Great. Okay, that's a great point. It's been a fantastic panel. Matthew, you want to go?
Yeah, thank you again for having us. And after going after both of them, I just have to say yes. Yeah, both of those things. No, I am very excited about all reality capture from all the devices. We're seeing so much improvement in the different types of scanners. Again, like talked about, from the phone to a mobile backpack to terrestrial scanners, and ways to capture data for construction, ways to scan entire airports for digital twin programs, ways to use it in forensics. We see so much capability out of the technologies. At this point, I believe that it comes down to, again, education around the applications. And then once you want to use them, making sure we're looking at the right tools and the right workflows. But I would just encourage anybody that is not already using any of these tools to absolutely look into them and connect with people that are, and ask questions and get started, because the demand for them is definitely growing. When I got started 13 years ago, there was nobody asking for scanning. The only time you did scanning is if you were on a project using it for your own use, or you went to a GC or somebody and convinced them to try it. Now that's changing. hospital renovations, airports, they're requiring laser scanning, they're requiring scan to BIM, they are getting integrated into so many project types that it also is creating massive opportunity. And the industry needs more people who become really good at these technologies. So I just encourage more people to keep looking into it. It's definitely part of the future.
Great encouragement. Thank you, Matthew. All right, Rex. First of all, I want to say thank you to the American Concrete Institute for pulling this panel together and really driving this conversation. But I want to give it to you, Rex, and ask for what your final words are.
This is one of many tools that we as an industry need in order to continue our progress in improving quality and productivity within the industry. So looking forward to seeing how we can use it, not only to review what we've done, but how we can look forward and improve on things, even to the point where these reality capture systems are identifying things that are missing and directing a picking robot and an automated autonomous mobile robot to fetch it and retrieve it, bring it to the worker and offer it to them so that they can install it. So it's a great topic. If you want to know more about ACI or how you can participate in committee work or certification or education, send me a note. You can contact me at innovation@concrete.org.
Very good. That's Rex Donahey. He's the Director of Innovative Concrete Technology at the American Concrete Institute. Right before Rex wrapped up with his final thoughts, Matthew Byrd, founder and president at Reality Capture Network and Nexus 3D Consulting. Boy, I really booted that one. Sorry, Matthew. And before Matthew, N.K. Chaitanya, the CEO at Constructn. It is a software SaaS product and also a portfolio company of Shadow Ventures, I should say that. And beginning our closing comments here, Eric Peterson, who is a director at Webcor Concrete Group and obviously a big participant in ACI committees as well. Thank you to all four of you for all of your thoughts, your insights, your expertise. This has been a fantastic panel, and to everybody that has been joining us live and commenting over there on the side panel, thank you to all of you. Again, you can rewatch this in a recorded version wherever you're watching this now, or go over to the Shadow Partners YouTube channel. You can find it there easily as well. This has been Reality Capture in Concrete Construction. And it's a Shadow Partners expert roundtable discussion brought to you by the American Concrete Institute. So thank you to all of you, and we'll see you again soon. I host a short form conversation every day at noon Eastern with people just like these on your screen. We call it Shadow Shorts, 10 to 15 minute conversations with experts and thought leaders in innovation for the built environment. So join me tomorrow at noon Eastern if you're interested in another deep discussion on innovation for the built environment. Thanks to all of you on our panel. Thanks to all of you that are watching us live and in a time-shifted version. And we'll see you again soon.
Thanks, Jeff.
All right. Thank you. See you guys.
Thanks, everybody.
Thanks.
Thank you. Okay. Bye.